Somewhere in southern China, a factory is producing an electric car that costs less than a base model gasoline sedan in the United States. Not a stripped-down golf cart with four wheels and a battery. A real car with real range, real safety ratings, and real profit margins for the company that builds it. Meanwhile, in Detroit, in Stuttgart, in Tokyo, engineers and executives are looking at the numbers on that same category of car and shaking their heads because they cannot figure out how to build it for that price even if they wanted to sell it at a loss. That is the mystery sitting at the center of this story. How does a company most Americans had never heard of a decade ago now outsell nearly every automaker on earth in electric vehicles, while still turning a profit on cars priced low enough to make Western finance departments nervous? The easy answer is cheap labor. The easy answer is government subsidies. Both of those things are part of the picture, but neither of them explains the gap. Plenty of companies have access to low-cost labor. Plenty of companies receive government support. None of them do what BYD does. The real answer is stranger, more disciplined, and more deliberate than most people assume, and it has almost nothing to do with cutting corners. To understand BYD, you have to start with a decision the company made decades before it built a single electric car. In the late 1990s, BYD was not an automaker at all. It was a battery manufacturer, founded by a chemist named Wang Chunfu, making rechargeable batteries for cell phones. That origin matters more than almost anything else in this story because it means BYD did not walk into the automotive industry the way Tesla did or the way traditional automakers did. It walked in from the inside of the battery itself. By the time BYD decided to build cars in 2003, it already understood something that legacy automakers were only beginning to grasp 2 decades later. In an electric vehicle, the battery is not just a component. It is the single most expensive and most strategically important part of the entire machine. Whoever controls the battery controls the economics of the car. That single insight set BYD on a path almost no other automaker was willing to follow, a strategy known as vertical integration. Most car companies, including nearly every major Western brand, build their vehicles by assembling parts made by hundreds of outside suppliers. Batteries from one company, semiconductors from another, electric motors from a third, software systems from a fourth. Each of those suppliers adds its own profit margin, its own lead time, its own risk of shortage, and its own negotiating leverage. BYD looked at that system and essentially said, we are not doing that. Instead, BYD manufactures its own batteries, its own electric motors, its own power electronics, many of its own semiconductors, and even much of its own software. It even makes many of the machines used to build its cars. This is not a small detail buried in an annual report. It is the core of the entire company, and it is the reason the price gap exists at all. Here is where the story gets more specific and more surprising. When the global chip shortage crushed the auto industry in 2021 and 2022, forcing Ford, General Motors, Toyota, and nearly every other manufacturer to halt production lines and leave half-finished cars sitting in parking lots, waiting for missing semiconductors, BYD barely slowed down. Why? Because BYD had already been designing and producing its own automotive-grade chips for years, through a subsidiary most people outside the industry had never heard of. While competitors were bidding against each other for scraps of global chip supply, BYD was pulling parts off its own production line. That single advantage during one crisis period tells you almost everything about the philosophy driving this company. Owning the supply chain is not about saving a few dollars per car under normal conditions. It is about controlling your own destiny when conditions are not normal, which, if you have paid attention to the last several years of global manufacturing, is most of the time. Now we arrive at the piece of technology that people in the industry consider BYD's single most important breakthrough, something called the blade battery. To understand why it matters, you first need a quick, honest picture of the battery landscape before it existed. Most electric vehicles for years relied on a battery chemistry called nickel manganese cobalt, or NMC. NMC batteries pack a lot of energy into a small space, which is valuable, but they are also expensive because cobalt is costly, geopolitically sensitive, and often mined under ethically troubling conditions. NMC batteries also carry a higher risk of thermal runaway, the chain reaction that can cause a battery fire. BYD took a different chemistry, lithium iron phosphate, or LFP, which had been mostly written off by much of the industry as too bulky and too low in energy density to be competitive. LFP does not use cobalt. It is cheaper, it is also significantly more stable and less prone to catching fire. The problem with LFP had always been geometry, not chemistry. The battery cells were shaped in a way that wasted space inside the pack, meaning you needed more cells, more materials, and more weight to achieve the same range as an NMC battery. BYD's engineers solved that geometry problem with a strikingly simple idea. Instead of building small, individually packaged battery cells and then bundling them into modules before assembling those modules into a pack, which is how nearly the entire industry has done it for years, BYD designed long, flat, blade-shaped cells that could be placed directly into the battery pack structure itself, edge to edge, with almost no wasted space. Picture the difference between packing a suitcase with individually wrapped items versus laying long, flat boards directly into the trunk. The blade design eliminates the wasted air and structural materials sitting between components, and by removing an entire intermediate layer of engineering, called the module, BYD increased usable space inside the pack by around 50% compared to conventional designs. That is not a marginal improvement. That is a fundamental rethink of how a battery pack is built. The result is a battery that costs less to produce, weighs less for the same range because you need fewer support structures, and passes safety tests that make headlines specifically because they are so dramatic. BYD has published video of a blade battery being pierced with a steel nail, a test designed to simulate a puncture from a road accident. And instead of catching fire or exploding, the battery simply smokes briefly and stabilizes. Conventional NMC cells subjected to the same test have been shown, in industry comparisons, to reach temperatures above 500 degrees Celsius and burst into flame almost immediately. So the blade battery is not just cheaper, it is a case where cutting cost and improving safety turned out to be the same engineering decision, which almost never happens in manufacturing, and that is precisely why competitors have spent years trying to catch up. But even a brilliant battery design does not fully explain the price gap, because a battery still needs raw materials, and raw materials still need to be mined, refined, and transported. This is where China's broader industrial ecosystem becomes impossible to ignore. China currently refines the overwhelming majority of the world's lithium and controls a similarly dominant share of global processing for cobalt and battery-grade graphite, even in cases where the raw ore is mined elsewhere. Because refining, not mining, is where much of the cost and complexity actually sits. BYD operates within a country that has spent over a decade deliberately building out this entire chain, from mineral processing to cell production to finished vehicles, often within a few hundred miles of a single industrial region. When a Western automaker sources battery materials, those materials might cross 3 or 4 international borders, each one adding shipping costs, tariffs, delays, and currency risk before the battery is even assembled. When BYD sources materials, much of that journey happens inside one country, often inside one industrial cluster, coordinated by a government that has explicitly prioritized this exact outcome. Then there is scale, and scale in China does not mean what scale means almost anywhere else. China is now the largest automobile market in the world, selling tens of millions of vehicles a year, and BYD sells the overwhelming majority of its cars right there in that domestic market before it ever ships a single vehicle overseas. That built-in demand allows BYD to run factories at extremely high utilization rates, spreading fixed costs like tooling, equipment, and research spending across a massive volume of vehicles. A Western automaker attempting to launch a comparable low-cost EV often has to justify that investment against a domestic market a fraction of the size, with far less certainty that the volume will materialize. Lower volume per model, spread across similar fixed costs, mathematically produces a higher per unit price before a single supplier negotiation even begins. Now compare that entire system to the way most Western automakers actually operate, and the contrast becomes almost uncomfortable. A typical American or European automaker relies on a web of hundreds of outside suppliers, each protecting its own margin, each with its own production timeline, each representing a point where things can go wrong. When Ford wants to redesign a battery pack, it often has to renegotiate with an outside supplier, wait for new tooling, and accept whatever price that supplier is willing to offer. When BYD wants to redesign a battery pack, it is making a decision inside its own walls. That difference sounds small on paper. In practice, it means BYD can iterate on designs faster, respond to cost pressure faster, and avoid the layered markups that come from 6 or 7 companies, each taking a cut of the same vehicle. Some analysts estimate that a fully vertically integrated approach like BYD's can strip out somewhere between 15 and 30% of total vehicle cost compared to a traditional multi-supplier model, depending on the component category. And when you are competing in a market where margins are already thin, that gap is the difference between profit and loss. None of this has stayed confined to China, and this is the part of the story many Americans are only beginning to notice. BYD has expanded aggressively into Latin America, becoming one of the top-selling EV brands in Brazil, where it is now building a manufacturing complex of its own. It has pushed into Southeast Asia, where it has quickly become a dominant EV brand in Thailand. It has entered Australia, the Middle East, and much of Europe, often undercutting local competitors on price while still offering comparable or superior technology. In many of these markets, BYD has never needed to enter the United States at all to become one of the most consequential automakers on the planet. Global EV sales figures released over the past couple of years have shown BYD trading places with Tesla for the title of the world's top-selling electric vehicle manufacturer. Depending on the quarter and how plug-in hybrids are counted, a reality that would have sounded implausible to most industry watchers just 5 years earlier. So return to the question this story opened with. How does a company sell electric cars at prices Western automakers cannot even manufacture them for and still make money? The honest answer is not a single trick, a hidden subsidy, or a shortcut around fair competition. It is the compounding effect of a company that started inside battery chemistry rather than backing into it, that chose to own its supply chain instead of renting it, that redesigned the physical geometry of a battery pack to eliminate waste, and that built all of this inside an industrial and geographic ecosystem specifically engineered over a decade to support exactly this kind of manufacturing. Each piece alone might save a company a few percentage points. Stacked together, across millions of vehicles a year, they add up to a structural cost advantage that competitors cannot close simply by trying harder or cutting quarterly bonuses. Which leaves the bigger question hanging over this entire industry, the one worth sitting with long after this video ends. Is BYD simply a well-run car company that made smart engineering choices? Or is it early evidence of something larger, an industrial system built deliberately over decades that is capable of reshaping who leads global manufacturing for the next generation? Cars have always been more than transportation. They have been a measure of national industrial strength, from Detroit's dominance in the 20th century to Japan and Germany's rise in the decades that followed. If China has genuinely built a manufacturing system capable of producing not just cheaper cars but better engineered ones, the story of BYD is not really about one company at all. It may be the opening chapter of a much longer story about where the center of gravity in global industry is heading next.